Hello, Mustafa.
Hello.
Can you hear me?
Yeah,
Yes. How are you?
good. How about you?
Thank you very much. Okay. Mustafa, I think maybe I didn't share this file with you. Maybe today I will share it with you. Okay. In the first chapter, we talk about real number system, right? In real number system, real numbers is the union of what is it? Rational numbers and irrational numbers. So we started with natural numbers, and after that, whole numbers and integers and rational numbers. And after that, irrational numbers, rational numbers, and irrational numbers together, they form real number system. And the equations, right? Absolute value equations and inequalities. And did we finish everything? Let me just have a look. Okay, the first one, inequalities, 5, 2. Okay, good. Okay, so today I will finish, start new chapter. The second unit is about functions and the relations, linear function systems. Okay,
hmm
Mustafa. And we have, I think, 4, 5, 6 different units here. All right. So let me just write the date and the starts, Mustafa. And what is that? Date is 24. Okay. Mustafa, now we are going to focus on two concepts now in this unit and in this, what is this lesson, relations and functions. Okay. This is one of the important units with concepts in math. When you just say relation in daily life situation, how these two things are related to each other, right? Connected to each other. This is how we use this. For example, how are you related to this boy? You can say that he is my cousin, right? And how you are related to this, he is my father's son, or not father's, my father's maybe siblings, one of the siblings, son or daughter, right? If he or she is your cousin. All right. In math, a set of ordered pairs is defined as relations. What is it? A set of ordered pairs. Like for example, in real life, we have a lot of relations. That's what is an important concept. If you go to Walmart, right, we have items and every item has a price, right? Now I can list this, apple, $5, pear, $7, sugar, $3, cheese, $15, right? So now if you just write these items with their price, they form a relation. Okay. Okay, let me just fill in these blanks and after that we'll talk more about relation and function. All right. So a set of ordered pairs. Okay, relation is simply a set of ordered pairs. What does set mean? A collection, right? In math, how do you define set? Set is a collection of well-defined objects, right? A set of real numbers, a set of natural numbers, a set of what is it, whole numbers. So relation means that a set of ordered pairs. So sets can be shown in how many different ways? Maybe you can show this in a table or in a mapping or what else? A graph, right? Or equation. And usually math, whatever you see here until now, right? They are, or they can be displayed in four different ways. Number one, in a table, right? Number two, graph. Number three, equation. And number four, also mapping. Okay. So they can be shown in, what is it? In, let me just write here, in a table. Okay. And the next one is, here we have mapping. Just write mapping. Or what is this? Table, or expressed as an equation. That equation part is the most commonly used way of representing what is this? Relations. So the set of x values is called, if you're given relation, like for example, let me just give you one example in table. Let me write here an x, let me write here y. Let's say when it is 1, it is, let's say it is 4. When it is 2, it is 5. When it is 3, it is, for example, let's say it is 6. Okay. So the set of this x values is called the domain, right? Domain means that you are receiving something for your machine. And after putting this and processing this, and the set of y values is called the range. You remember the things you studied this in Algebra 1. Okay. So domain and the set of y values is called the range. A relation with distinct points. Distinct point is called discrete. Okay. A relation with connected lines or curves is called continuous. These are just basic concepts, okay? And the most important thing is understanding the relation, okay? If something is given a set of values, a relation in which each element of the domain is paired with exactly one element of the range. That's the definition of the function. Our main focus is on this concept, function. And you have to know this definition, if possible, memorize this, okay? And the whole chapter is about a function. What is a function? Function is a special relation. It is a special relation. What kind of relation is it? In which each element of the domain is paired with exactly, this is the keyword here, exactly one element of the range. That means that you have a kind of machine, right? You're putting something, processing this. It must give you only one item, one output. Then we call this is a function. If it gives like 2 or 3 different values, it's not called a function. And why is it so, Mustafa? Because in real life, a lot of things, the result is only one result, not 2 different results. For example, as I told you, if you go to the market, every item has a single price, right? And if you measure the height of the people in your family, everybody has one height, right? Or if you measure their weight, everybody has a single weight, right? Or if you're doing some experiment, let's say on a tree, every day it is growing. Every day, if you measure, you just get only one measurement. At one time, it doesn't have 2 different heights. And that's why actually a function is very important concept. Okay. So can you read this one more time? You're going to read this every time I will ask this because it must be a piece of cake for you. You should understand this concept really well. What is a function? Function is, read it.
A relation in which each element of the domain is paired with exactly one element of the range.
Okay, here, domain, let me just put all the values here. And here we have range, all the values here. So that means that if you just pick any value, right, it must be mapped to single value here. We call this y. Through what? F. We have a kind of function, it's processing. It gives us a single value. When you practice question, you'll understand, we just need some time. Example for function, suppose that we are given this kind of graph, okay? So graph is something like this. Suppose that it is something like this, okay? So that is the graph of the function. For each value, if I draw a vertical line, you see here, it crosses at 1 point. If I draw here, 1 point, which means that every x value is producing a single value. And how about if we have a graph like this? Okay, something like this. Suppose that we have something like this, okay? The graph. Now, if I just draw a vertical line, one vertical line, x value here is producing 2 different values here. That's why it's not a graph of the function, or this graph does not specify a function. Okay? So that means that in a function, x values do not repeat. Okay, here we have function. So what is a vertical line test? And I think graph should be here. Yeah, graph should be here. Let me draw the graph. It's already here. Okay. Let me draw the graph here. It is something, for example, you can do any kind of graph actually. I can draw something like this, or I can draw something like this, for example. Okay. Here, vertical line test, it is not a function. And this one, any vertical line, there's only one intersection point maximum. And for a function, okay, for a function, I can write here 1, let's say 1. And 2, let's say it is 4. It is 3, it is 9, for example. Another function, what is that? Here we have 1, it gives us a 3. Again, here we have 1, it gives us 5. The same input value is producing 2 different values. Let me write here 3 and 7. It's not a function because this x value is repeating. Okay. So two things, Mustafa. Number one, what is a relation? Relation is a set of ordered pairs. And how about a function? To define a function, you should know about relation. Function is a special relation where each element of the domain is mapped, right? Or paired with exactly one element of the range. You don't have to memorize it, but you should understand the concept. If you just pick any element from the domain and put into your function, it must produce a single value, single output. Then this relation is called a function. Okay, so now let's practice to find the domain and range. What is domain, Mustafa?
The x value.
The set of x values, right? Range,
Mhm. The range, um, the set of y values.
very good. That's this. Okay. What is a relation? It is a set of ordered pairs. Domain is the set of x values. Range is the set of y values. Function is a special relation where every element of the domain is matched or paired with exactly one element of the range. Okay, because if you understand the meaning of these words, you can learn math really well, easily. Otherwise, every time you have question mark. What is it? What was that? You try to remember. Okay, directions. Find the domain and range of each relation. Then determine if the relation is a function or not. Okay, what is the domain of this function? I'm a relation. I don't know yet. Is a function or not? -1,
The
right?
domain is 1, 0,
0,
4,
4, and 6, right?
6,
X values. Then how about the y values?
negative
-9, right?
9, negative
0,
5, and
4, and 6. Is it a function? Look at the x values. Do
wait,
they repeat or not? No, right? Then yes, it's a function. Why? Because we don't have any x values repeating, right? Repeats and two different values, then it's not a function. So -1, 0, 4, 6, all input values are different, right? That's why it is a function. And how about 2? What is the domain?
5, negative 3, 5, and 8.
8, right? When you're listing the elements of
Uh,
the set, Mustafa, we do not write a single element twice. Just one time is enough. That's 5 represents 5. And how about the range? 2, right? And 4,
4, and 0.
-6, and 0. Is it a function?
No.
No. Why? Because this 5, right, and 5, one input value is producing two different output values. That means that each element of the domain is not matched or paired with exactly one output value. That's why it's not a function. Okay, now how about the table here? This one is set form. How about if the relation is given in a table? Domain,
Hold on.
7, right?
If there's two y values,
2,
right?
0, -4, right? Domain, right? And range? Yes, Mustafa.
Negative 8, 3,
-8,
negative, and
3,
3.
-1, and 3, right? And 3 is repeating, so we
Mhm.
don't have to write twice. Just write one time in a set. Is it a function?
Yes.
Yes, because all input values are distinct, right? They're different. That's why it's a function. For domain,
10, 15, 18, 24.
18 and 24. Range,
0, 3, 7, and 11.
11. Is it a function?
Yes.
Yes, because all input values are distinct, right? They're different. That's why it is a function. And how about in the mappings? Domain, x values,
Negative 4, negative 2, and 5.
and 5. Why, range,
0, 3, 7, 9.
7 and 9, right? Is it a function?
Yes.
No,
Wait. No, 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 my bad. No.
because 5 is mapped onto two different values, right? One input is producing two output. That's why it's not a function. 6,
2,
2,
8,
8,
13,
13,
and
and
17.
17, right? Range,
-4, 0, and 7.
7. Okay. Is it a function?
Yes.
Yes, all input values are different. That's why it is a function. Now, how about if you're given a graph? How do we actually identify that or determine that it's a function or not? So we have to use vertical line test. It's a theorem. Sure, it's a small theorem, okay? What does it say? If we draw a vertical line at any point, right? If it meets only maximum only one point, then it's a graph of the function, or it represents a function. Otherwise, it's not. If it crosses like 2 or 3 points, it's not. Look at this first. Let's write the domain. What is the domain of this relation?
The domain, 1, 2,
The first one is from left to
3,
right. This one is -3, right? The
negative
points. Because what is
3,
the first point?
0.
1, 2, 3. It is -3 and 1, right? And next one is -3 and -2, right? And the third point is 0, 1, 2, 3,
And then the
4.
third,
Next one is 0, 4, right? And next one is 2, -1,
hmm
right? Can you see that? And the last one is 1, 2,
hmm
3, 4, 1, 2, 3, 4, 5. So that is 4, -5. So the domain is -3, 0, 2, and 4, right? X values, because every point can be represented by an ordered pair of numbers. And how about the range? Can you tell me the range now?
1,
1,
-2,
-2,
4,
4,
-1, and
-1,
-5.
and 5. -5, right? Okay. Is it a
Uh-huh.
function?
No.
No. Why? Because it fails vertical line test. If I draw a vertical line here, it actually passes through two different points. That's why it's not a graph, or it does not specify a function, or it does not represent a function. Bless you. Okay. Water.
But just like Algebra 1, because we
Hmm?
learned this last year. Isn't this Algebra 1? Because like we learned this last year.
No, no, no. In Algebra 1, you study some basic things. In Algebra 2, you just go a bit deeper. In pre-calculus, you go deeper. Again, you will see this in pre-calculus. And again, you will see this when you take
Uh,
calculus class at university. Because these basic things, this function you study in grade 6 and grade 7 and grade 9, each time you go deeper and deeper. All right, now you will see that this one is a bit, how to say, it covers more different problems. But this function, topic function, in every level, starting in grade 7, you will see this. Okay. Now, algebra 2 is function. The topic is linear function. And next year, again, in algebra, what is the pre-calculus? You will see that one topic is function, but wider, different examples. When you take calculus, again, you will see functions. When you go to university, again, you will see this, but covers, wider, what is it? More different topics. Okay, this is just introduction. Our main topic is about the functions, how to calculate this, and that's why you have some idea. We should go a bit faster. Okay, Mustafa. All right, question 8. Now, what kind of function is this?
this one, um, what type? What do you mean? What type of
Linear
function?
function, right? Look at this graph. What do we call such function? It's a linear function. Again, in algebra 2, you learned it. What is the equation of this one? The general equation is, it is mx plus b, right? I don't have to write this, but actually should identify that, you should recognize that this one is a graph of a linear function. So what is the domain of linear function?
on the domain.
Yeah.
Um, 2
All real
and then
numbers.
0. Oh,
All real numbers. Anything can be the domain, right? Because it's a continuous function. You see, we said that we're talking about two different functions. What is it? It is discrete and the continuous. This one is continuous line, right? That's why it's called continuous function. So it is
yeah.
domain or range will be an interval. And how about the range? Range is also all real numbers. Okay. And how about question 9? Look at this. What is the domain of this relation? Number one. And after that, we will decide as a function or not. So that is, this one is a function, right? Because it passes the vertical line test. If you draw any vertical line, there will be only one intersection point. Now look at question 9. What is the domain of this function? So domain means, once again, it is the set of x values, right? So what are all possible x values for this function? I mean, sorry, not function, it's a relation. Actually, it's not a function.
Um, all real numbers.
No. If you look at this, all the graph is to the right of this line, right? Can you see that?
Huh?
To the left, you don't have anything, right?
Oh,
So x values are starting from here. 1, 2, 3, 4. So starting from -4 to positive infinity. And how about the real number? How do you know that, Mustafa, to find the domain? Okay, you have to put your pencil, if you're doing it on the paper. Just scan this from left to right, starting with the leftmost point, right? And scan this. So that is from left to right, that's the domain. And how about the range? To find the range, you have to scan your pencil horizontally from the bottom, from the lowest point to the highest point. Now, because of this, this arrowhead, what does it mean? It means that it just keeps going down, right? And upper part, it just keeps
mhm.
going up. That's why range is all real numbers.
Hmm.
Okay? This is what you should be really comfortable with it, because it's a very important basic concepts in algebra. It doesn't matter, algebra 1, algebra 2, pre-calculus or calculus. These are very basic but important topics. Is it a function? No. Why? Because if I draw a vertical line here, right, it fails the vertical line test. I have two intersection points. That's why it's not, or it does not represent a function. Okay? All right, now look at question 10, Mustafa. What is the domain of this graph in question 10?
The domain. Does it even have a domain? It's a
Hmm?
circle.
What is it?
Um,
You see, if you put your pencil, Mustafa, this is my pencil. I start for the first time here, right?
uh-huh,
I'm scanning to the right. So that point is
uh-huh.
1, 2. So starting with -2. Now I'm scanning to the right and until here, right? So that one is 1, 2, 3, 4, 5. So 5, right? That is a domain. To the left of -2, to the right of 5, we don't have any part of the graph. And how about the range? The lowest point. Again, I'm scanning. Actually, put your pencil here. The lowest point is here, 1, 2. So it is from -2, scanning upward, 1, 2, 3, 4, 5, 6. Here we have 6. That's the range. So what does it mean, Mustafa? It means that if you just pick any value from its domain, from this interval, and you will see the graph some point between -2 and 6, right? The output value. It means this. For example, let's say this point. So either I get this point or this point. And if I take this point, for example, it produces either this point or this point, right? So is it a function? No, because it fails the vertical line test. Okay? All right. That's why in Algebra 1, you get some basic idea foundation. Now we are building on this. Okay? In pre-calculus, you build more. In calculus, you build more. Okay? In general way, you can define a function so that you can imagine that everything can be described using function. That means that you need a bit deeper knowledge to visualize this. 11. Look at this and tell me what is the domain of this quadratic function? Actually, it's a quadratic function. And quadratic functions graphs are parabola, right? Yes.
The domain would be negative x to the power of 2.
No. What is the domain? What are the possible input values for x? What numbers can be replaced for x here so that we can calculate?
Oh,
Any number, right? If you tell me any number, I can square this, right? And I can multiply by -1 and S3. So that's why domain is all real numbers. If you look at the graph, you see, okay, y is equal to minus x squared plus 3, right? You see, that's a graph. Now it just keeps going down. If I move down, you see it never stops. So that's why domain is all real numbers. But how about the range, Mustafa? The range, as you see here, negative x squared y plus 3. So this x squared is always non-negative. If you multiply by minus, I have here something like this. I can rewrite this as 3 minus x squared, right? And minimum value of x squared is 0. So maximum, if you look at the graph, you don't have to look at the graph actually, but look at the equation, you should be able to answer the question. Look at the graph, that's the maximum value. See, x equals y is equal to 3. The whole graph is below this line. So then what is the range? Range is from negative infinity to -3 because the maximum value is -3. Okay?
wait, isn't the maximum 3?
Yeah, this is the maximum value, right? You see above this line, we don't have anything. The whole graph is below this line. Can the value of
But
y be like 4 or 6 or something? We don't have anything above this line, right? But going down, it just keeps going down, right? You see? Just keeps going down, right? But maximum, the highest point is here. Okay, range means that if you're walking the mountain, the highest point and the lowest point. But here, it just keeps going down. It doesn't have the lowest point, but it has highest point, right? Okay, next question. Y equals -5x minus 1. Again, it's a linear function, right, Mustafa? Its graph is a straight line.
wait,
And what is its
so
domain? Huh?
is number 11 a function or no?
Number 11 is a function. It is a function.
Okay.
Function means that, Mustafa, if you substitute something for x, right, and evaluate this, you will get a single value, right? That's why it's a function. Y is alone on the left-hand side and x's are on the right-hand side. It's a function. And how about 12? What is the domain?
The domain, all real numbers,
All real numbers. It's a linear function. That's why it's all real numbers. Range,
range,
all real numbers, right? Also,
uh,
because of linear function. Linear function domain is all real numbers, and the range is all real numbers. Is a function? Of course, yes, it's a function. And 11 is a quadratic function. And what is a quadratic function? The general form of quadratic function is f of x is equal to ax squared plus bx plus c. We will learn about this soon. Okay. How about y equals -7, Mustafa?
oh, it
What
would be
does its
negative.
graph look like? Is it a kind of curve or a straight line? If it's a straight line, what kind of straight line is it?
I'm not getting any audio. I
Really?
can't hear what you're saying.
Why? I think maybe because of your earphone. I have no problem with my. Let me change
Mm.
this to Is it because of my internet connection?
Hello?
Yes, give me a second, Mustafa.
I can hear you now.
Okay. Anyway, let me just change to another line so that maybe. Okay. Do you hear me well now, Mustafa?
Mm-hmm.
Okay. Now we are talking about this y equals negative
Mm-hmm.
7. Can you draw its graph? Hmm?
12.
13.
Wait, which one?
13.
13?
Question 13. Y
The
equals negative 7.
domain. Um,
Y equals negative 7 is a straight line, right? It's a horizontal line. It's parallel
mm-hmm.
to the y-axis, I mean x-axis. Look,
Yeah.
if I draw here, y equals negative 7. It's just a straight line. Is it a function? Now, first tell me, what is the domain of
Yes.
this function, this relation?
The
Is it?
domain of the function.
Yeah, domain of this relation. For this relation, then we will decide.
Um, Domain would be, wouldn't it just
Look at the
infinity?
line. It's all real numbers, right?
Yeah, all real numbers.
Or negative infinity, infinity. How about the range?
The range, um, wouldn't that also be all real numbers?
No, it's only negative 7. It has
Or
only
no,
one
negative
value, right?
7 to all real numbers.
Yeah.
I mean,
Is it a
to,
function?
um, yes.
Yes, because if you draw any vertical line, there will be only one intersection point. And how about x equals negative 1?
Um, it would be all real numbers for the domain.
No. Look, x equals negative 1. It's all a single value. What does domain mean? The set of x values, right?
Oh,
So this x
yeah,
has only one value. So it's negative 1.
negative
So it is
one.
something like this. What is it? Coordinate system. Okay. X equals
It
negative
would be a
1. It is
straight
this
vertical
line,
line.
right? It is this line, negative 1. And how about the range? All real numbers. Is it a function? Does it specify a function?
No.
No, because if you do the vertical line at negative 1, it has infinite intersection points. Okay, Mustafa. That's
Uh-huh.
just, introduction part. Now let's talk about function, how to evaluate its values. Okay. Okay. Now, Mustafa, equations that represent functions are often written in function notation. Why is it so, Mustafa? Because it's easy to see that at what value I am evaluating the value of the function. I can write it as y equals to x plus 7. But instead of this, how about if I write here f of x is equal to 2x plus 7. And also I can write function as f. And what is the advantage of writing with like this, f of x, g of x, h of x? So number one, I can give a special name to my function. For example, if I'm talking about time, I can use t of x. If I'm talking about distance, I can read d of x. If I'm talking about the cost of items, right, I can use c of x. X is a number of items, right? This is one thing. I can name the function. Number two, I can see that here the independent value is x, or I can see easily at what value I am evaluating the value of the function. Okay? So here, what is x? X is the input, right? X is the input, and y is the output value. Okay, x is input, y is output. So can you read this part? Evaluating functions. What do we do to evaluate the value of the function? Read this function notation.
Function notation is specifically useful for finding a value in the range that corresponds to a certain domain value.
Okay, that
Example,
course.
if fx equals 2x plus 7, find f negative 3.
You see, actually, when we are calculating this, I can see that I am evaluating the value of the function at -3. Our function is given here, 2 times x plus 7. What is our function doing here? Whatever you input, right, it multiplies by 2 and adds 7. That's what our function does here. If I evaluate here f of -3, so wherever I see x, I have to replace it by -3. I have here 2 times x. What is x? -3 and plus 7. 2 times -3, -6 plus 7 is 1. So that means that the value of the function at -3 is 1. So if I'm making a table, now I can see that x and y, when x equals -3, the value of the function is 1. Okay, and after that we plot this point and connect them to get the graph of the function. Okay, now can you read this?
Use fx equals
F of
negative
x.
5x minus 14 and g of x equals negative x to the power of 2 plus
Just put it
9x
as negative
minus
x
1.
squared, Mustafa.
Okay. Negative x squared plus 9x minus 1.
Okay,
Can is that all right if I go blow my nose real quickly?
yeah. Just give me water.
Yeah, I'm back.
Okay, Mustafa, let's continue. Let's do it together, okay? And the next question, you'll do this. So now you get the idea. Now here, f of x, right? So to evaluate this f of -9, f of -9, so I have to replace all x's by -9. -5 times -9 and minus 14. -5, -9, 45, minus 14, that is 31, right?
Mm-hmm.
Okay. Now let's do this f of 3 over 9, -5 times x. That is 3 over 9 minus 14. Can you simplify this, Mustafa? And try to do this question without using a calculator. If it is so weird functions, then we will use a calculator, okay? After all, we are doing here mental
Mm-hmm.
exercise.
Okay. Mm,
So 5 times 3 is 15, right?
Mm-hmm.
15 divided by 10 is 1.5. So negative 1.5 minus 14 is negative 15.5, right? Okay. Do question 3,
Mm-hmm.
Mustafa, or let's do question 3 together. You'll do question 4. So 0.4
Mm-hmm.
equals, so here we have minus 0.4 squared plus 9 times 0.4 minus 1 equals, what is 0.4 squared?
Um, 0.4, 0.8. No, wait.
0.16.
4 times 4 equals 16. 1.6. Yeah, 16.
0.16, right? And the
Mm-hmm.
plus 9 times 0.4 is 3.6
Mm-hmm.
minus 1. So 3.6 minus 1 is 2.6, right? And 2.6
Mm-hmm.
minus 0.16, it's like 2.6 means that 260, right? 2.6 minus 0.16. So 0.16, which is equal to, what is it? 10 minus 6. It is 4. 5 minus 1. 5 minus 1 is 4 and 1, right? So that's equal to minus 1.44. Okay, the small numbers do mentally or in the paper, and it's really actually what is it helps you to calculate things faster because also we have the price and very weird numbers at that time we'll use a calculator. Mustafa, do the next question. What is g of negative 7? Can you calculate it yourself?
Mm-hmm. Mm,
Calculate in the paper, then we'll check the answer together. Okay. First substitute and
mm-hmm.
the calculate. Slowly, slowly. Yes, Mustafa.
I'm almost done.
Mm-hmm.
And then negative 15.
Negative 15? No.
Yes.
Look, Mustafa, negative 7 squared, 49, right? So here we have
Mm-hmm.
minus, so that is negative 49. And 9 times negative
Oh.
7, negative 63, right?
Uh-huh.
And negative 1. All of these numbers are negative. So that means that we have to combine them, right? 49 plus 1, 50. 50 plus 63 is negative 113. Okay?
Mm-hmm.
All right. Now, how about this f of 1 minus f of negative 4, right? So write the first one f of 1, write in bracket. So that is negative 5 times 1. I don't have to write 1 minus
Mm-hmm.
14. Okay. Minus now f of negative 4 is a function. Okay. Write in bracket negative 4. So negative 5 times negative 4 and minus 14, right? Then we calculate this. Negative
Mm-hmm.
5 minus 14, negative 19, minus negative 5 times negative 4, 20. 20 minus 14 is, it is 6. So negative 19 minus 6 is negative 25. Okay. So can you do question 2?
Mm-hmm.
Do question 2.
Mm-hmm. Oh.
Yes, Mustafa.
Uh, 502.
502? No. Why so
Yeah.
big? Look, Mustafa, here we have two times, okay? I just keep it here. Now let's calculate what is g of 12.
Mm-hmm.
So here we have minus
Mm-hmm.
x. X is 12 squared plus 9 times 12 minus 1, right?
Mm-hmm.
Okay. So equals 2 times. And 12 squared is 144.
Uh-huh.
And here we have minus. So that is minus 144 plus 9
But
times 12 is 108.
wait, since it's negative 12, wouldn't that become 144?
What?
When you multiply the negative 12 by negative 12, won't that become 144? Since negative times negative equals positive?
No, no, Mustafa. If you remember, we talked about this before, right? It's here. Or, okay, not yet, I think. So, Mustafa, if we have something like this, negative, let's say 12 squared, okay? So this means that negative 12 times negative 12, that's equal to 144. But if we have like this, negative 12 squared, so this means that here we have negative 1 times 12 squared. And what is the order of operations, Mustafa? If you remember PEMDAS, right? First parenthesis, then exponents, then multiplication, division, then addition, subtraction, right? So here we have exponent. First, I have to raise this to the power of 2. So I have multiplication negative 1. 12 squared is 144. And negative 1 times 144 is negative 144. If it is like this, Mustafa, for example, let's say f of x is equal to x squared. If I have to calculate this at negative 12, then I write here negative 12 because x is negative number squared, then that's equal to 144. But if it is, if our function is like
Oh.
this, g of x is equal to minus x squared, then g of 12 will be equal to minus 12 squared. That's equal to negative 144. Okay?
Mm-hmm.
All right. So that's why negative 144. 9 times 12 is 108. 108 minus 1 is 107. Equals 2 times negative 144 plus 107 is negative 37. And 2 times negative 37 is negative 74. Okay? All right. You have to practice more, Mustafa, because once you understand that, you will see that you go really fast. But in life, a lot of things, it depends on your practice. Allah created like us. Maybe some people without practice they can learn, but they are maybe one actually out of 1 million people. But we people we like you and me, ordinary people, if you want to be good at something, we need to practice more and more. Okay? That's the only way. Without practicing, you may have knowledge, but to be able to do things fast and think well, we need to do practice. Okay, Mustafa, let's do this question, okay, quickly and finish the class. This only
Okay.
4 questions. Okay. Now use p of x that's equal to 1 over 2 minus 4 over 3 times x. That's also a linear function. And here we have absolute value function. Okay, so P, you have to do this question in P if possible. 1 over 2 minus 4 over 3 times x. X, instead of x, I'm going to write here negative 9 over 16. right? And actually, we did this in the first unit, uh, how to calculate this. Minus minus, it is plus. And 9 over 3, it is 3, right? I have at the top, it is 3. And 416, also, they're both divisible by 4. I have 4 here. Common denominator is 4, right? 2 plus 3 is 5. If you can do at this speed, it will be really great. Okay, it's about actually simple numbers, but as you practice more, you get fast, faster and faster. And what is the advantage of this? It actually trains your brain to think fast, which is very important skill, right, in life. So you can make decisions fast, you can think fast, you can calculate fast so that you can be better than other people. And how about this question 8? You will do 9 and 10, okay? Question 8, Q of
Mm-hmm.
5 equals, so our function is this, absolute value, 3 times 5 minus, and here we have 5 cubed, which is equal to 15 minus 5 cubed, 125. And 15 minus 125 is negative 110. And absolute value of negative 110 is 110. Okay. In algebra 1, you calculate this
Mm-hmm.
kind of thing, but basic ones, simpler functions. But this one is a bit more complicated, involving more different operations. Okay, Mustafa, do question 9 and 10. We will finish the class. Now do question 9 first.
Mm-hmm. Okay. Mm-hmm.
Mustafa, did you finish 9?
Almost. I'm just kind of confused on a part.
In what question? 9?
Mm-hmm.
Here we have q of negative 2, right?
Mm-hmm.
Our function is absolute value, 3 times negative 2, right?
Oh,
Minus,
wait, that's the absolute value one?
yeah.
I was doing P on accident.
No, it is q, right? Q.
Mm-hmm.
Okay. Minus 2 cube.
Mm-hmm.
And now let's do it together. Here we have, what is 3 times negative 2?
Negative 6.
Negative 6. And what is negative 2 cubed?
Uh, 8. Negative
Neg-
8.
Negative 8. And negative, negative, positive, right?
Mm-hmm.
And negative 6 plus 8 is 2. Absolute value of 2 is 2.
Mm-hmm.
And how about 10? So P of 18. It's really simple, right? Just
Mm-hmm.
plug it and calculate. That's it.
Mm-hmm.
1 over 2 minus 4 over 3 times x. What is x? 18 equals
Mm-hmm.
1 over 2 minus 18 divided by 3 is 6. 6 times 4 is 24. And what is 1 half minus 24? That is negative 23.5 or 23 and a half. Okay, Mustafa.
Mm-hmm.
Mustafa, I will send this to you.
Um,
Yes. You want to say something?
my mom said that she wanted to talk with you at the end of the class, if that's all right with you.
Yeah. Mustafa, I will
Okay, let
send this
me.
to you. Okay. You have no
Mm-hmm.
idea. Try to solve as many questions as possible. Okay. If you do this,
Mm-hmm.
so like linear relationship next time, we'll talk about this one and it'll go really fast. Okay. But of course, if you don't do this,
Mm-hmm.
I cannot move to the next topic without practicing or
Mm-hmm.
seeing your work. Okay, Mustafa. Yeah.
Okay. Okay, let me go call her.